So I'm giving this talk on behalf of really a lot of the partners and collaborators at Open Networking Lab. And those of you who do not know what Open Networking Lab is, we're going to probably, pretty soon tell you more about it, and hopefully you'll get to learn. And this is a little bit different than vendor-centric. This is more of a talk on, I need to learn how to switch this. Let's see if it works. Up, down. Oh. Okay, perfect. Great, thanks. Okay, so the talk is more related to some of the work that has been done at Open Networking Lab and on behalf of the other partners at Open Networking Lab, which includes Verizon, SK Telecom, NTT, China Unicom, and other partners, vendor partners. So this is a sort of a joint effort and has been coming along past 2 years. So this talk is more presenting what the CORD mission is, and obviously CORD stands for Central Office Re-Architected as a Data Center. You're going to hear a lot of that. And I'm going to provide you some, as I'm describing what CORD architecture is, I'm going to give you some use case examples, some of the incentives and some of the stakeholders, why we are doing this. In addition, some of the dimensions of the CORD is what we are focused on today in an agile method as compared to some of the roadmap and some of the potential lab trials that's going on that hopefully is going to happen and are happening. And the need for why do we need open, basically, CORD platform. And we're going to discuss some of the architecture aspects and we're going to go through some of the residential CORD, enterprise CORD, and mobility CORD. And we talk about some of the tangent aspects of that with respect to analytics and so on. So as you see here, this is the current examples of the central offices. There are a large number of central offices. They have evolved to become a museum, right? And there are obviously about 300 plus types of equipment with huge source of CapEx and OpEx. And the idea is to be able to transform this into a white box, bare metal architecture where we can pick up basically some of these white box solutions all the way from layer 0 to layer 7, right? When I talk about layer 0, I mean transport on packet on the optical layer and maybe physical layer on the RF side. And when we talk about maybe higher layers, we're talking about layer 2, layer 3, and so on with the VNF capabilities. So this is sort of the architecture model for all the CORD projects that we are talking about. And on the right side, we are showing the ROADM, which is right now not disaggregated, but we went and we demoed really some of the work, for example, for the eCORD on the disaggregated ROADMs, or we call them open ROADM. I would also suggest you guys take a look at openrodm.org from AT&T, which was announced at OFC, in a sense. So what's the mission here? The mission is really delivered to service providers, obviously, right? It is economy of the data center. That's where, in order for us to compete better, we really need to get to that economy of the data center, how they launch, how they innovate, and how they provide services, and have that agile environment where we can innovate with our partners and vendors. So with that, the infrastructure builds in a data center environment with a few commodity building blocks, right? White boxes, nothing proprietary, not yet another box, based on open source software and white box. John Donovan of AT&T have been on Keynotes a number of times, and he's been publicly saying that he wants to make sure by 2020 we have perhaps 40–50% based on open source. 75% of our network should be virtualized, so you should see that. And agile in terms of software platforms that can enable rapid creation of new services, where we can innovate, chip vendors can innovate, basically vendors from box vendors can innovate, and carriers like us, we can innovate together, and we see the value and we can share that value. So therefore this reference platform, right? So let's look at the history of the CORD, right? CORD really started as a use case for ONOS. And those of you who don't know what ONOS is Open Networking Operating System, which was initiated obviously back in 2007, SDN at Stanford, but we collectively with the partners, they put together this open source network operating system that's available to everyone to look at and play around with. And CORD has gained sort of tremendous momentum from that, building the infrastructures and the services around ONOS with some of the service examples and use cases of which relates to residential, mobility, and enterprise core. And we have basically are ready to do some field trials with the core, residential core, and mobile core and enterprise core were demoed at the ONS 2016 back in March, and also at OFC. We took the e-core there to showcase basically packet optical over open ROADMs. So the core project will offer open reference implementation of the core, which is, I'll tell you more about it in terms of the hardware specs and platform software and some of the services. We'll trying to help the users get the core pods operational quickly, giving them the blueprints and be able to field trial that, and we can talk about the roadmap of that a little bit later, and help the users explore new service opportunities. Users, including the startups, the innovators, and vendors, be able to support some of that, and obviously continue to nurture and support growing community to contribute to this. So it is not really just one thing, proprietary approach and all of that. So now that you know what core is, let's look at some of the players here that I'm standing up here on behalf of some of them, to talk to you about this. ON.Lab, which is really a non-for-profit organization, part of Stanford. And Guru, who is really leading the Open Networking Lab. I think you guys should meet him and he's been working with various academia and industry, and he's sort of leading us towards that. And some of the service providers that are active partners, and we have many of them who are supportive, and in other service providers that are not here, they are there. And then vendors who are helping us making this happen are listed in the community, such as Ciena, Alcatel-Lucent, or now Nokia, Ericsson, Fujitsu, Intel, NEC, Huawei, and so on. And obviously, we have collaborators, vendor collaborators that are actively working with us, and you're going to see a list of them later, maybe, hopefully soon, and many communities. So the communities are in hundreds, if you add them up in terms of people and organizations who are supporting us. And so these are some of the collaborators and contributors, examples of them, and they are day-to-day. They have people at Open Networking Lab, and we are constantly talking to them in day-to-day operation. They are working with us in the meetings and all of that. In fact, we had a bunch of meetings with some of them this morning, just alone fixing, our roadmaps, how we are going to about to make stories around what we are going to showcase next. So important infrastructure, core central office is obviously, is an important infrastructure for carriers, and this is where we possibly see the differentiators, where we have access very close to the customers. Basically, one of the central office could support 10,000 residential, 10,000 mobile subscribers or plus, obviously 10,000 or plus, and maybe many enterprise customers, right? There are thousands of them in our networks, bigger, some companies like AT&T has thousands of them. We already announced publicly how many, but I'm just going to leave it at that. And it could be a gateway. This is where the gateway to the customers are. This is where we could have the smart cities, IoTs, and mHealth enterprise customers come to the central offices for these services that are VNF-based, you guys that have been working on, and so on. So perfect timing. You guys have been making great progress in the VNF, in some of the virtualization aspects, some of the programmable hardware-based solutions, and it sounds like we are getting a lot of traction, and we all understand that no longer we want yet another box, and we are trying to go personalizable hardware equipment and infrastructures and all of that. So, and the reason that core now is in place to just show that we can in fact do that, right? We want to do rapid innovation, not just with our vendors that we are working with, but everyone, with the ecosystem, including the chip vendors. Be able to do quick deployment, put the customers in control of their own services in terms of customizing, personalizing, and be able to have service programmability, application network aware, and we talk more about embedded analytics. I know I've seen a lot of analytics questions and discussions on the floor, but I'm going to tell you a little bit more about what really means embedded analytic means and virtual probing means as well. And obviously with low cost for OpEx, and agile development style where we can launch services in weeks or maybe days instead of months and years in a sense. And basically repersonalizable hardware. And that's sort of the key to those developments. So with that, code is an attempt to sort of create an environment for virtualization, for delivery diversity, for intelligence, based on these commodity functions, the storage, computing, and control, basically, in a sense, I guess the storage, computing, and networking, and obviously control, which is as part of it. So the fundamental units of code. Now with that, we want to sort of be able to say that we want to support any kind of service with that, right? From residential to mobility to enterprise, right? Using the same infrastructure, same environment and all of that. And the architecture that you see here is ONOS as a SDN, at least that's what ON.Lab is looking at, but there are other obviously operating systems, other controllers. There are OpenStack, which we are taking advantage of. XOS is anything as a service which was developed at ON.Lab, which is really nothing but orchestration of or service composition layer that takes advantage of some of the OpenStack environment. And leafed spine, white box switches, with a set of basically commodity servers and storage servers, access points on both sides. From the left side, these are the residential access points to mobility access points to optical access points, all the way to the right-hand side where we have the ROADMs, and even that is going to be white box. That's sort of the model. So let's look at it from software perspective, right? With respect to core pods, right? They basically are managed by these controllers, and operators will provide the models such as Yang or Tosca to provision what the network capabilities, features are. And on top, we'll have basically customers in control. We have lots of analytics, allocation. Some of the Tabasco sauce will go on top, and those could be proprietary in nature, and vendors can bring to the table in a sense. So if you go one level deeper, right, the core internal view, if you look at it from residential subscribers' perspective, right, so we have these controller for virtual optical line terminators or serving gateways or virtual routers. ONOS itself is sort of a service or a tenant. Monitoring engines, service monitoring, virtual CDN, caching. So all of those are basically have each of them logical controllers under maybe instantiation of the service composition at the higher level, which is XOS, we call it here, or anything as a service. And we have to use basically these models because we want to be agile and we want to quickly deploy. So somebody can make XOS to become a service to their own orchestrator, or it can be replaced by their own orchestrator in a sense. So here is an example of residential gateway, how we did the demo and how we are doing some trial among this. On the right-hand side, you see that basically spine and leaf model that we have. We have the access point, which some of the access point on the virtual OLT has been, the MAC layer has been basically disaggregated, and some of the virtual OLT and virtual serving gateways have been into the VM on top, residential services on top. And obviously, other, compute and all of that, will be supported on those servers. So service providers portals will be able to instantiate the policies. The third-party providers portals, they can come up with their own policies, for their own residentials, or even customers can do, for example, parental control, and there is a subscriber portals in a sense. So third parties could be an MVNO model, if they want to manage their own localized environment. And on the left-hand side, these are very inexpensive, Netgear and, WRT operating system and a GPON on the left, and very simple models. So all the services have been pushed to central office under control of either the customer or the operator in a sense. So open reference platform, I guess, if you want to look at, we've been looking at the blueprints for these, right? How can we go take it to the OCP, Open Compute Platform, make sure that everything that we are doing with respect to code is certified, right? These are the servers that are OCP certified, or switches that are OCP certified that we can go pick and choose, from Acton of the world and other, communities. And for example, from fiber to the home as a service to all the way to software as a service. So anything as a service is the model. And obviously, we are looking at the test infrastructure. We are looking at some of the core components of this core platform, which really is the OpenStack, ONOS as an SDN, XOS as a service composition, and OCP models or the environment for the OCP. And the domain services that we have picked are R-Core. With that are services that we can launch, virtualizing the optical line terminators and so on. E-Core, we are carrier-grade OpenCE type models, virtual OEM, virtual firewall. So these are the services that can be controlled by the customers themselves. Mobile Core, which I'm going to instantiate a little bit more about it. It has to do with virtualizing what Nokia mentioned about some of the RAN and the core part of the aspects of that. And obviously, there are other monitoring services, And so Ciena and Radisys will be providing the turnkey core pods. So there are support for it. They have stepped up saying that Radisys is going to be the integrator for the core part, and Ciena have said that we are going to support ONOS. So it's commercial version of it and capabilities. And on top of that, we are talking to other basically partners and integrators that they can look at it from system view. If we had to do this potential sandbox around the world, how do we do this orchestration end-to-end? So E-Core, let's talk a little bit about E-Core. Now, taking the same infrastructure, this is more of an enterprise core, right? This is where MEF, wants to make sure that the Metro Ethernet services or, they're based on OpenCE and, LSO model and all of that. So we basically said, okay, we want to be able to do virtualized network on demand. We want to be able to do customer control, and we want to be able to have innovative services, right, in terms of security policies and control and all of that. So we went and we basically created this environment, based on open on the right-hand side, very right, my right-hand side, basically, or your right-hand side. It is where we demonstrated this Ethernet services or enterprise core on open ROADMs, right? We took the transponders disaggregated from the ROADMs, and we had multi-vendor environment there. And on top, we are showing that we have ROADMs going to the metros, and this, the muxponders or transponders going to the spine switches, and then we had a fiber switch that interconnected these things together, per se. And we were able to show that we have programmable backplane between the ROADMs and the transponders, and optical bypass within the central office. We can actually pseudo-wire some of the traffic from one central office to another, in a sense. And all of those based on white box. The partners that we demoed this with back in June was Uplink, Lumentum, Ciena, Fujitsu, Caliant, right? And those are mainly on the optical side of things, and we were packet layer like Cavium and others helped us, on the upper layer aspects of it. Some of the services that we were able to show was basically ELAN and E-line, for both multicast and unicast. And the multicast, I think, is yet to sort of show it as a scalable fashion, but at least we showed this. We actually, on the left-hand side, this is the representation of what the ONOS discovered. Those are the instances of ONOS. On the very corner, you see you can instantiate multiple ONOS instances to be able to scale this up. So each ONOS instance is responsible for part of the network, but they are consistent, right? They're eventually consistent in a sense that applications only sees one network. And that's sort of the beauty of the SDN abstraction model. So E-Core, I guess showing this in a form of, logical sense, this is really enterprise customers with enterprise, customer premises equipment. They come into the enterprise subscribers. This is where we are controlling this virtualized environment from all the way from monitoring to virtual firewalls to virtual CE and virtual routers and so on. So a common platform with basically domain-specific services. That's really the goal objective of the core. Now, let's go look at the core one more time, right? The core is basically we are saying that with core we can support residential, enterprise, and mobility. Now, if you dive into mobility, that's where I sort of want to take you slowly, right? With the cross-layer design and optimization of the core for mobility in mind, we want to be able to take advantage of the spine and leaf that we have. Same spine and leaf that supports residential, should support service function chaining, network slicing, RAN disaggregation, and mobile edge, right? And so let's sort of dive into that very quickly. So you guys are familiar with this model. So we are approaching the same model here now. We want to disaggregate the RAN, we want to disaggregate the EPC, and we want to do mobile edge services, right, in a sense of caching at the edge and so on. So let's look at the example of what we did here, right? So we wanted to sort of take the traditional architecture of 3GPP. We said, can we do this on basically target architecture, right? The target architecture is our core environment in a sense, right? So on the left is a 3GPP model, and we try to take a small step with the agile way. Within 3 months, we put together a roadmap with our partners, such as Cavium and Radisys and NEC and others. We put together an environment. And now we are going forward with second rack because we have so many people who want to participate in this. So we're going to have rack 1 and rack 2, I'll call them, or maybe mobile core 1 and 2. We're going to be doing the roadmap towards disaggregation and virtualization model of the RAN. We basically want to open up the wireless interfaces. We want to be able to disaggregate and virtualize some of the evolved packet core, separate the control part of both RAN and evolved packet core, and bring them up to the above SDN. And then we want to be able to show that we can handle performance, we can handle IoT services, virtual reality, mHealth, education, and so on, right? So that's sort of the model. Now let's look at, again, this is what we did. We basically, we created virtual BBUs, we created virtual MMEs, serving gateways, and we took some of the control out of each of these to show that solution exists, right? We took some of the control from, for example, packet gateway, and we brought it up to the above the M-Core model where we had disaggregated mobile edge services. We showed that. So this was the model, right? I'm just going to skip that because this was very familiar to you guys. We just took the same infrastructure and we basically put ONOS and CDN and packet gateway and all of that with their own control models and all of that. So what we demoed at the ONS was sort of showed both a edge services and a core services, where edge could be anywhere, could be either a central office or even closer to the customer at the basement of Kaiser, for example, where we could provide caching as a service, DNS as a service, security as a service, and we can basically classify potentially the users that need to get core services, or they can go to a central office or wherever the core is, right, the mobile core services. So either through using the control from SDN, different form and shapes that we've been discussing and all of that. So since I'm running out of time, so let me, I think I have a couple of more slides to go, right? So one is that, this is really the goal towards really 5G, I believe, right? We want to be able to show RAN disaggregation by opening up the interfaces. We want to show evolved packet core disaggregation, connectionless services that doesn't require barriers and GTP tunnels, the overhead that today we have. Our Nokia friends know what I'm talking about. And obviously real-time analytics that are embedded in the eNode Bs and edge, and where we want to be able to talk a little bit more about this quickly, where we want to have the embedded virtual probes at all the way from VMs to the containers, to the chip level, to the interconnects at the chips, right? And that's where we want to be able to do instrumentations as a service. We want to be able to get these embedded analytics enabled for the applications to do their jobs. So the last two charts, one is that we are talking, and actually engage with some of these, for example, BBF and MEF. They want to adopt these platforms as a reference platform for the standard bodies that they are looking at. And the idea is to be able to work with them, and I think ON.Lab is open to work with any, and basically any standard bodies. IEEE guys are involved to some degree, and we are hoping to get others involved too. So in summary, Core is a new open source project by ONOS partnership and the Linux Foundation. We want to basically get the leading service providers together, be able to participate and work together and contribute. And residential code kind of is ready for lab trials and a little bit of a field trial. And we also demonstrated M-Core and E-Core at the ONS and OFC, and we are ready to basically get those to the next steps as well too. We are delivering all of these based on white box and reference platforms, and these are open rags, and we are committed to basically open source from ON.Lab and partners perspective to do strong communities to come together to really have agile deployment and all of that. So with that, I want to thank you for your time. And